Hello. In the following examples, we're going to figure out if the graphs are symmetric with respect to the origin. A is saying x squared plus y squared equals 16. In order to test for symmetry with respect to the origin, I replace both the x and the y with negative x and negative y respectively. So when I do that, that gives me negative x squared plus negative y squared equals 16. When I simplify, that gives me x squared plus y squared equals 16. And this is the same as the original equation. Therefore, yes, this does have origin symmetry. The reason this works is because if you were to graph this, this would be a circle centered at the origin of radius 4. Now notice that this quadrant, quadrant 3, and this quadrant, quadrant 1, are the same as one another. They're just a reflection across y equals negative x. And the same for quadrant 2 and quadrant 4, except they're a reflection across y equals x. Or another thing you can think of is taking this entire function, flipping it upside down, and asking, does it look the same? Yes, it does here, and that's another way of seeing that this is origin symmetry. Next, let's look at letter B. Letter B is y equals x cubed. Again, for origin symmetry, what I need to do is I need to replace the x and the y with negative x and negative y respectively. So that gives me negative y is equal to negative x cubed. When I simplify, that gives me negative y is equal to negative x cubed, because this means negative x times negative x times negative x. So 3 negative x's multiplied together gives me a negative, and then x cubed. This is not the same as the original, but notice what happens if I divide by negative 1. When I do that, that gives me y equals x cubed. So notice that y equals x cubed is the same as the original equation. Therefore, yes, this is symmetric with respect to the origin. Now, obviously not all equations will be symmetric with respect to the origin. I just wanted to show you a couple that did. Notice that if I was to graph this, this would look something like this. It's the y equals x cubed function. Again, notice that quadrant 3 is a reflection of quadrant 1, and quadrant 2 is a reflection of quadrant 4. Also notice that if you turn this upside down, it looks the same. And that's another way of seeing that yes, this is symmetric with respect to the origin.